In this video, I want to explain a little bit more in detail about factoring trinomials and using a very systematic approach rather than feeling like it's just random and guess and check. And before we get into factoring, let me review a different way to multiply two binomials together, and I'm going to use that in just a minute to reverse the process to factor. So 3x plus 5 times 2x minus 3, we could simply FOIL if you want to use that, or distribute, right? But I'm going to use a box method, so I'm going to write one of the binomials on the top of the box and the other down the left side of the box. So we'll write 3x plus 5 across the top, and then 2x minus 3 to the left of the box. And now we're going to multiply these terms right in the grid, so I would have to distribute. 2x times 3x is 6x squared. 2x times 5 is 10x. Negative 3 times 3x is negative 9x. And negative 3 times 5 is negative 15. And then to get the final product, I have to add like terms. So I would have 6x squared. Notice on the diagonal, 10x minus 9x is plus x, and then minus 15. So this product is 6x squared plus x minus 15. And our whole goal is to think about, if we're starting with the trinomial, how can we obtain these two binomials whose product is that trinomial? Some really cool things I want you to notice in this box method. Notice that the product of the diagonals is the same, right? 6x squared times negative 15 is negative, what is that, 90x squared. Negative 9x times 10x also has a product of negative 90x squared. And then the other thing I want you to observe is that negative 9 and 10 also add up to be 1, right? Which is a coefficient of the middle term. So the 6x squared and the negative 15 are in our boxes, but the x is actually coming from two boxes. That is a negative 9x and the 10x. So their product is negative 90x squared, but their sum is x. So keep that in mind. Let's do one more. 4x minus 7. So I'm going to write that across the top. And then x plus 4. And then distribute. So x times 4x is 4x squared. X times negative 7 is negative 7x. 4 times 4x is 16x. And 4 times negative 7 is negative 28. So when I combine these like terms, I get 4x squared. The 16x minus the 7x on the diagonal is plus 9x. And then minus 28. So this product is 4x squared plus 9x minus 28. So some other interesting things here. The product on the diagonals, 4x squared times negative 28, is negative 112x squared. And 16x times the negative 7x is negative 112x squared. So what you also observe between the 16x and the negative 7 is that 16 and negative 7 add up to be 9. So notice that 16 times negative 7 is negative 112, but their sum is 9. And where's the negative 112 coming from? Well, that was from also 4 times the negative 28. I also want to point out one other thing about these two problems, which I think is so cool. Let's look at the rows and the columns kind of independently. Between 6x squared and 10x, so this first row, what is a common factor between 6x squared and 10x? Well, it is 2x. What's a common factor between negative 9x and negative 15? What is negative 3? And now looking at the columns, what's common between 6x squared and negative 9x? That happens to be 3x. And between 10x and negative 15, it is plus 5. The terms in the binomials are actually common factors of our rows and columns. That same thing is true here. Like between 4x squared and negative 7x, the common factor is x. 16x and negative 28, the common factor is 4. Between 4x squared and 16x, the common factor is 4x. And between negative 7x and negative 28, the common factor is negative 7. Now let's look at a trinomial and try to factor it by applying what we just talked about. We have 2x squared plus 15x plus 28. Using this box method, I know that the 2x squared goes in the first column, first row. 28 is in the second row, second column. And I know that 15x is going to come from the diagonal. So my diagonal terms need to add up to be 15x. But what do they need to multiply to be? Well, they have to have the same product as the other diagonal. 2x squared times 28 is 56x squared. So I know that whatever I put in this diagonal, they have to multiply to be 56x squared, but add up to be 15x. So don't think about the variables for just a moment. Let's think about the numbers. So that means we need to find numbers that are factors of 56. So they multiply to be 56 and add to be 15. So if I think about the factors of 56, obviously 1 and 56, 2 and 28, 3 doesn't go into it, 4 and 14, and then 7 and 8. So which in this list has a sum of 15? Well, that is 7 and 8. And it doesn't matter where I put the 7 and 8. I'll put the 7x in the top row and the 8x in the second row. And then all I'm going to do is find the common factors of the rows and columns. So finding the common factor of 2x squared and 7x, the only thing that's common between 2x squared and 7x is x. What's common between an 8x and 28? 4 goes into each of those. So plus 4. What's common between 2x squared and 8x? That would be 2x. And what's common between 7x and 28? That would be a plus 7. So the factored form is 2x plus 7 times x plus 4. Let's do one more. 8x squared minus 14x minus 15. So if I'm trying to factor this, the 8x squared goes in the first row. The negative 15 goes in the second row, second column. And I want the terms on the diagonal to add up to be my middle coefficient, which is negative 14x. But I need them to multiply to be what was on the other diagonal, 8x squared times negative 15. That's negative 120x squared. So the product needs to be negative 120x squared, but the sum needs to be negative 14. So we need to find numbers who are factors of negative 120, whose sum is negative 14. And so let's not think about the signs right now. Let's just think about 120 first. So thinking about all the factors of 120. So 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8 and 15, and 10 and 12. I need to think about, first of all, to be in negative 120 and have a negative sum. That means that when I add the two numbers, the larger one's going to be negative. So we want to think about a negative on the larger of all of these numbers for the product to be negative and for the sum to be negative. And then I'm looking to determine which one has a sum of negative 14. Now, as I look down the list, that comes up at 6 and negative 20. So I'm going to put in a 6x and negative 20x, and again, it doesn't matter the order in which you put those numbers in. And then I'm just going to find the common factors of the rows and the columns. So the common factor between 8x squared and 6x, 2x goes into each of those. The common factor between negative 20x and negative 15 is negative 5. What's common between 8x squared and negative 20x? 4x goes into each of those. And between 6x and negative 15, 3, so plus 3. So my factors are, reading across the top, 4x plus 3, and then down to the left, 2x minus 5. And if you FOIL that out, you'll see that you will get this trinomial. So I hope that helps. I mean, there is a trial and error where you could look at what are the factors of 8, what are the factors of 15, and just arrange them until you get the right combination. I could write this whole process out a little bit differently. It's called the AC method. So I could do this. And I don't want to confuse you too much, but I could say what's 8 times negative 15, which we already found was negative 120, and figuring out what are the factors of negative 120, whose sum is this negative 14. And so I could come up with this 6 and negative 20, so it's very similar. So I would replace negative 14x with a plus 6x minus 20x, and then minus 15. And the difference here is that I would have to use grouping to factor this instead of that box method. I think the box method really makes things easy because you're just looking at the rows and the columns. But here I would have to group the first two and the last two together. So between 8x squared and 6x, there is a 2x common. And 2x into 8x squared is 4x. 2x into 6x is plus 3. And then between negative 20x and negative 15 is a negative 5. And when I divide by negative 5, I get a 4x plus 3. And so now there's a common binomial of 4x plus 3, and that leaves 2x minus 5. So either method is going to get you there. Just use whichever one you are more comfortable with.